Hello, everyone. Thanks very much for being here, and I want to personally thank the committee for accepting my contribution. I'm Allessandro Ansani, and I'm currently a postdoc researcher at Roma Tre University. And my core research, I would say, that deals with the influence that soundtracks exerts on the interpretation of audiovisuals, of several kinds of audiovisuals. Now, soundtrack has several psychological functions. These, for instance, have been listed by Ann-Christine Herget in a beautiful review that I suggest to. It dates back to 2019, so a couple of years ago. And I was wondering whether beyond the classical functions, psychological functions of the soundtrack, which are well known, no? By movie director and also by psychologists to some extent, I was wondering whether the soundtrack can also have this function of altering our time perception during a scene. So basically, this is what this study is about. This presentation relies on a paper that I published 2 years ago. And first things first, a little bit of literature here. Now, as far as I studied, the influence that music has on time perception and time estimation has been studied into two big families. So the indirect measurement studies and the direct measurement studies. When we deal with indirect measurement studies, we basically deal with weight and times. So, as I say here, a bunch of studies focused on how music alters time perception in, retail settings, restaurants, queues, and on-hold call center scenarios. And generally, it seems that the mere presence of music increased the waiting time. So the participants waited for a greater amount of time. So this implies a time underestimation. And it seems that this effect is even stronger with when liked or slow-paced music is involved. As regards the direct measurements, these are studies wherein the experiment basically asks the participants to evaluate the length of musical excerpts. And here I confined myself to concentrate on valence and arousal. And there's evidence that positive affect music fosters time underestimation, and the opposite is true, of course, for negative affect music. Whereas contrasting results, I would say, exist about arousal. Here I listed several studies with the musical factor on the left and their effect on the central column. But here I came up with a slightly different study because I wanted to investigate this phenomenon in an audiovisual context. So not merely a musical excerpt, but an audiovisual excerpt. So this was basically an online experiment. There was this short movie called On Lockdown. And together with my co-authors, we realized 5 versions of this short movie. Now, four were with a soundtrack, and one was with no soundtrack, so with no music. And no, I don't know if you're able to read the chart, the table over there, because I think there will be my ugly face over there. But however, anyway, I just chose 4 soundtracks that could have all the possible patterns of valence and arousal. For instance, if you take a look at Appalachian Spring, which is the first one, then you see there is positive in valence and arousal, both in valence and in arousal. Whereas if you take a look at Murder, for instance, the third one by the Newton brothers, a very scary piece, and you have negative valence and positive arousal, of course. So this was basically the experiment, and the dependent variables were self-reported affective state, the self-reported level of arousal experienced by the viewers, and the perception of the elapsed time. The hypotheses were coherent with the studies that I was showing you earlier. So currently with the studies on waiting times, the mere presence of music should lead to an underestimation of time. This would be even stronger with positive valenced music. And as for the arousal, according to a couple of models, of counting models, the models that deals with how we perceive time that I don't have time to show you at the moment. The hypothesis was that the arousal level should lead to an overestimation of elapsed time. I will skip on this part, but long story short, we had 565 participants divided into five conditions. Now, what about the assessment? As for the affective state, we used the well-known Plutchik's wheel of emotion. It was a pretty easy task in that the participants just had to click on the region that best represented the emotion that we were feeling while viewing the short movie. And subsequently, we codified the emotions, the chosen emotion, as in 3 levels, I would say. So +1 for the positive emotions, -1 for the negative, and the neutral emotions, such as expectations, had 0. I know that this is a controversial part. Maybe we can discuss about this later on. And there were 2 sliders. The first one for the arousal. So please rate the extent to which you felt active or awake, ready, and excited, which is the one below. And then there was this slider analyzing the time estimation. The final measure was, of course, the self-reported time minus the actual time elapsed, so it's easier to be processed. Let's jump to the results. Here there's the first bad news, I would say, because if you take a look at the, let's say, 6 o'clock region of the Plutchik's wheel of emotion, which is, by the way, sadness. I'm sorry for the Italian labels, but I'm pretty sure you all know about this wheel of emotion. So the 6 o'clock region, I was saying, is pretty warm. It's always crowded in all the conditions. So this is not a good news, because I thought that the visual part of the short movie was pretty neutral from an affective point of view. It turned out that it's not neutral at all. But if we take a look at these heat maps in a subtractive fashion, so in like in fMRI, for instance, we can see that there are some warm regions. For instance, in the relaxation and the happy conditions, there's the 12 o'clock region, which is serenity and joy, which is very crowded, very warmer, as opposed to, sadness. And instead, if we take a look at the scary condition, then we have the 3 o'clock region and 4 o'clock region, which is fear and apprehension, which is warmer than in the other conditions. So I would say good manipulation, not exactly the best one, maybe. And here you can see exactly the same result with the codification. So when you see the blue is -1, so negative affective state, and the yellow is, of course, the positive, and the gray one is the neutral one. Now, this distribution is pretty, I would say, very satisfying from a manipulation check point of view. And let's jump to the verification of the hypothesis. As for the first one, contrarily to the hypothesis, the control group actually reported the video to be significantly shorter as opposed to the music group. And in particular, the difference is minus 21 seconds for the scores are minus 21 seconds, so an underestimation of 21 seconds for the control group and 13 seconds for the music group, which is kind of unexpected, but we will explain this later on. Here you can see the same violin plots with all the conditions separated. The 0 is, of course, the correct estimate. And as for the hypothesis 2 and 3, it's maybe better to take a look at this little path analysis that I've built. Now, at the first level, you have music arousal and music valence that are basically codified, manually codified. So the scary soundtrack and the happy soundtrack as musical arousal equal 1, no music is equal 0, and the relaxing one and the sad one had -1 in the music arousal. The same thing applies, of course, for music valence. So with +1, -1, and 0. Then at the second level, we have the self-reported scores of arousal and affective state. And the third level is, of course, the prediction or the time estimation. Now, the first part, the first arrows from level 1 to level 2, I would say that they can work as a manipulation check. And as you can see, the music arousal, for instance, positively predicted self-reported arousal, but not self-reported affective state. And the opposite is true for music valence. So it just predicted the affective state, but not the arousal, the self-reported arousal. But if we take a look at the last part of the path analysis, we can see that the self-reported arousal is the only good predictor of the time estimation in a positive fashion. So the higher the arousal, the higher the time estimation. What else? Yeah, so this is the conclusion I came up with. Of course, this is a shortened version as opposed to the paper. Music nature seems to be twofold in this case. When it's reproduced in background, as in the waiting times and direct studies, it might be conceived as a distractor that draws the attention away from the conscious time perception. Whereas on the contrary, when it's paired with a visual stimuli, it kind of becomes a new layer of the meaning of the scenes. And this new layer requires an integration process. And this integration process requires additional attention and memory. And memory resources, of course, does lead into time overestimation. There are many limitations. So, for instance, no consideration for the musical fit, which can alter the degree to which the attention is focused on the audiovisual, of course, and can also lead to cognitive dissonance phenomena. We didn't consider the the preferences for the music preferences, I would say, and the movie preferences. And as I was saying, the short movie was not at all neutral. I'd like to replicate this study with eye tracking and pupillometry. I'd like to check whether pupil dilation as a proxy for arousal can predict time estimation. I've seen that there's a couple of studies in this direction, so I would like to do this in the audiovisual domain. And I'd be really curious to replicate it with a longer scene to see whether the effect resists, becomes stronger, or disappears. And I'd like to thank you for your attention, and I'm eager to answer your questions, to your questions if you have any. I'm really sorry, I'm recording this while I'm sick, so I'm not at my best. I'm really sorry about that. I hope I've been clear enough for you guys, and I look forward to hearing your questions. Thank you very much.